Hello, welcome back. In this session, we are going to talk about Amazon Bedrock Agent Core Memory. Memory is one of the most important aspect of building any AI agents because you need to keep the context of what was the conversation with the users in the past, and then for the current user question, the conversation you had with the user could serve as a context. Best example is if you can go to ChatGPT, it knows that what you've been talking with ChatGPT even for some weeks and months also, and then it can give you a response, for your current question, taking that context. So that's what we're going to discuss about how what is the memory and what is a short-term memory, what is a long-term memory, and then we're also going to see a demo of actually building an AI agent, both the short-term memory and then long-term memory. With that, let's get started. So we have two types of memory for an agent. One is a shorter memory, other is a long-term memory. So we have shorter memory which captures a raw conversations events as they occur. So they are stored in chronological order and it allows the agent to maintain immediate context during a single sessions. So the shorter memory also can help the user to maintain a real-time contextual conversations. So understand multi-step workflows and recall recent user messages and the tool response. Whereas long-term memory, which stores extracted insights such as user preferences or some semantic facts and some session summaries that persist across multiple sessions. So even if user comes back after a few days or a few weeks, the long-term memory can retrieve that and then provide that personalized experience for the users. So this shorter memory or long-term memory, the main intent is that this will help in providing a personalized, a context-aware agents that remembers your preferred, coding style or some domain facts or maybe summarizing past sessions. So these short-term and long-term memory together enable agent deliver very a kind of a personalized experience because it maintains the context across the sessions. Now let's take a closer look and deep dive into how short term memory works in Bedrock Agent Core. And after this, we'll also see a simple demo of building a LangGraph agent and then using the Bedrock Agent Core, shorter memory. So shorter memory by design is to store a raw interaction that helps the agent to maintain a context within a single sessions. So each of these interactions is recorded as an immutable event and they are organized by both the actor ID, that is the agent ID which is using, and the session ID. So this allows the agent to respond intelligently by referring back to the recent conversation turns without requiring the user to repeat themselves. So user is asking some questions, it doesn't have to, it can remember that the user is asking to book me tickets for this, from this place, and they suddenly they change their mind, or they might say, I want a business class, I want economic class. For every question you have the basically shorter memory in a way also have makes agent very stateful. It knows what has been discussed between each and every question. So Bedrock Agent Core provides mainly four primary operations to interact memory. Number one is create event. This allows us to store conversational exchanges or structured data in a very immutable fashion or as immutable events in the session timeline. And then we are having get event is used to retrieve specific event by ID, very useful when the agents need to recall key moments in the conversations. And list event gives ability to retrieve a full or a filtered conversation history of session, so that when if you're the agent starting, it knows that what has been discussed, it can have all conversations. And finally, delete event supports privacy and control by removing specific events when they are no longer needed. So together, these APIs makes it possible to build agents that are not only responsive, but also very importantly, they are aware of the context, leading to more, a personalized experience for the end customers. Now we are going to look at a LangGraph agent with the AgentCore memory tool. Okay, so we are building a simple agent which is for a personal fitness coach agent. So if you see the architecture of this agent, you are having user will question. So we are having an agent running locally, or you can also run this agent in the agent core runtime the way I showed in another session. So you can also run this. Maybe for this example, we can run this agent locally in this notebook, but it interacts with the agent core memory, which is in the Bedrock memory, shorter memory in events. So we are having a simple tool called list events to see what we are being storing in the memory. And then we'll invoke an Amazon Bedrock model. We'll use Anthropic models for Azure LLM. Right? Very simple tool. You're having a LangGraph agent, which is having a one tool called list events, which stores into all the conversations into memory. We'll see how it stores in the coming code. So first we have to install all the libraries, which I have already done. So next one I'll do is I will first import, and then I'm setting some basic things like setting the the region, and then logger. So importing memory client. So first thing is that I'm creating a memory client, okay, and then I'm naming that memory client as a memory name as a fitness coach, right? So this is my memory client, and then I have initialized memory client for in US West 2. Let's understand this part, very important code. Now we are creating memory. So to create a memory, we need to first, this is the let's understand the different variables. So we are having description strategies. You don't pass in strategies for shorter memory. This is for long term memory. We'll discuss about the different strategies when we come to long term memory. And then we are having some events like how quick, when this memory expires, and then what is the maximum time to wait for memory creation, and how often I need to poll. So once it does, it creates memory ID. We are also logging this memory ID, right? And then this is the method. We are creating the memory, and also we are having a method to delete the memory if user wants to delete the memory based on the memory ID. So now I am executing this also. So it is creating the memory. So basically, since this has already been run, it is saying that memory already exists. I am using the one which is already available. Right? Now we are importing all the LangGraph required libraries. These are all like LangChain, LangGraph libraries, standard libraries. So I made another set of videos on how to build the multi-agent using LangGraph. You can refer those things. But in this session, I am not going in details of how the LangGraph works, because the focus is mostly on how to create the memory for the agent. Now I'm creating a simple agent here. Let me walk you through that agent. So the LLM we are using is Bedrock agent, and then we are using Anthropic. This is a temperature for the model, and then I'm having only one single tool that is called list events. What this tool will do is it will list all the items we stored in the memory. Okay, all the events we stored in the memory. So we are passing memory ID, actor ID, session ID. It is shows up 10 results. It will list for you. Okay, so this is the only tool we are having, and we are actually binding this tool with the LLM. We are having these tools and then binding this tool with LLM. So now we are giving a system message. So you are a personalized fitness coach, a fitness assistant. So what is the purpose? The purpose of this fitness coach is to develop a workout routine based on what is user preferences, limitations, and also provide a personalized fitness recommendations. So we are also saying that you have access to recent events, list event tool. So we are telling this agent that if you want to access the previous conversation you have with the user, you can use this tool. This tool internally is talking to the Bedrock agent memory, Bedrock shorter memory, and retrieving all the events. And this is our chatbot method. It is taking the message from the raw message from user, and then this is all about invoking the LLM tools. It is invoking this agent, and then beyond that we are having typical LangGraph where we and one important thing here we have to note that every time a conversation is there, it has to store both the user message and both the response also into the shorter memory. That is what is happening here. It's creating this conversation, and this conversation is using this create event method. It is storing in the shorter memory of the agent. And then they're having a graph. We are building a LangGraph here. We're having one node called chatbot. We are having a tools node, and then we're having conditional edge to make sure that it verifies that for the tool condition, and then we are setting entry point as chatbot. This is a typical line graph where it's having the nodes, edges, the conditions and everything. And then you can refer all my previous videos on some more details on how the line graph, adding a node, what node means, what is the edge means, what is the conditional edge means. I have explained all of them in detail in those videos. So let's create this agent. Now this agent is created. Now we are having a wrapper method where we take the prompt from the user and then invoke the agent we created. Okay, so now apart from that, we are creating some actor ID to identify the user who is interacting with my agent, and also some session ID to map the session ID, because whenever I'm retrieving sessions, I have to try only the messages related to that user, maybe on that session. So that purpose I require some unique identifier for this user and unique identifier for this session. Now I created this agent with now you can see that client, memory ID, and then session ID. We create this agent. We are calling this create agent method, and then now that we are having agent ready, now is a time for us to test. So now I'm asking, this is my first day, I need a workout routine. Okay, and then I'm calling this agent. So you can see some warning because it is trying to by default LangChain try to log into LangSmith. For some reasons, if my LangSmith authentication, I didn't pass the LangSmith authentication details, it will show through this error. But the fact is, you can see here that the agent came back some response. Okay, it is giving you, it is what is your fitness goals, how much experience you have, and it is asking all the questions. See, now it is storing all these conversations in the memory. It knows what user preference is there. Now user says I want to build muscles, looking for bicep routines, and I have some lower back problems. So it is giving, now it is again executing agent. It has created some workout routine for the user based on what the user has provided. Right now all these things are stored in the memory. If you see, the question user has the response, the conversation, and this question and this response are already stored. You can see that when you say it retrieved total of 4 events in this one. The reason being, for example, since even though I ran this agent few times sometime back, so it is already having 4 messages in this, 2 now and then 2 in the past. Now we can also test the memory whether it's persisting or not. Now I'm asking, I'm actually creating a new agent, okay, and then I'm saying, hey, can you remind me of my last workout session? Let's see what happens. Now we can see it remembered what was the sessions based on the previous conversation. It looked like you last focus on bicep routine that took into your lower back issue. The key details are, this is what you want to do, this is what I provided. Now you can see that user doesn't have to remember everything. You are providing a personalized experience for the user. This is what a shorter memory is all about. So what we have learned right now is that we actually created an agent. We create actually memory for the memory client. By using the create event method, we actually stored all the conversations of the user in this session into the shorter memory, and then we have used that in the agent tool so that it can retrieve that information using the tools. For example, when the user asks, can you remind me of the last workout session, the agent knows that to get the last workout session, it has to use this particular tool. Okay, the reason being, we have provided the doc comment here that use this tool when needed, retrieve the recent information. Okay, so when user says that can you give me my recent, it knows that it has to retrieve this tool, and this tool in turn is invoking the memory which is having all the previous conversations. Okay, so this is about the Bedrock. You can also you can delete the memory just to avoid everything. If you want to clean the memory, I can just click on clean here. This is going to clean all the it will delete all my memory which I stored so far. Okay, so this is about the shorter memory. Next we will see the long-term memory, how we can store the memory beyond sessions, maybe few days or few weeks. Now let's talk about how long-term memory works in Amazon Bedrock Agent Core, how it goes beyond just remembering recent chat history. So long-term memory is built through a background process that continuously learn from short-term memory. So whenever you are having a raw conversational events are stored using the create event operation, that data can also feed into the long-term memory asynchronously. So the process is, it is like a four-step process. One is that in the stage one, it is like event creation. Every interaction, whether it is a question the user is having, a response given by the agent, or a tool usage is stored as an immutable event using the create event API. This serves as a foundation for both short-term and long-term memory. Next, extraction. Bedrock then extracts key pieces of information from those raw events. For example, you are discussing with your agent about your preference about the meal or the flight preferences, or some goals you are having, some fitness goals you are having, or maybe some FAQs. You are discussing all these things. Basically Bedrock is trying to extract the behind the scenes. It is trying to extract the key information from the conversation what you are having with the agent. Then comes the consolidation phase. In this phase, all the extracted insights are merged with the agent's existing long-term memory, allowing agent to develop a more persistent understanding of the user. And finally, retrieval. When needed, the agent can perform semantic search over its long-term memory, retrieving relevant knowledge to answer the questions we related to the with the more context. So while shorter memory helps the agent respond in the moment, let means I'm having conversation user, like what was my conversation last 5-10 minutes is what handled by the shorter memory. Long term memory goes beyond that. It just long term memory is not about just retrieving something which user is asking. It's all about learning the pattern. It is learning the preferences. It is actually building insights over time asynchronously. Like mean every time you are chatting, you are actually talking to the agent. The long term memory is learning from your conversation, right? So this will help making conversation more personalized, and then and also give the user the precise answer they're looking for instead of asking all the details again. So when we usually building AI agents, to make the agent truly personalized, we need to just go beyond storing the memory. We need some type of a smart memory strategy to store the you know the user conversations or interactions in a very intelligent way. So that's where Amazon Bedrock Agent Core supports multiple memory strategies that help agent remember the right things in the right way. Number one, the strategy, the four main strategies are summarizations. So basically this compress long conversation into brief summaries. So helping the agent stay within the context limit while still remembering the overall dialogue the user had with the agent in the past. Next is semantic memory. This strategy allows the agent to store and retrieve facts or learn knowledge almost like a knowledge base that grows with every interactions. Third one is user preference. This strategy captures person setting like a tone of the voice, a preferred tool or domain specific jargon, and apply them automatically in future response. So of course you can also have your own custom strategy, and you can use built-in strategies that are automatically managed by Agent Core, or if you want to have more control on how you want to store the long-term memory, you can build your own custom strategy using a tailored prompt and model to suit your requirements. So for example, you are building a coding agent, say. So you know that you prefer particular type of a case. You want to have the comments in certain fashion, and you know that you are using pandas for analysis. So even if you come back days later, it applies those preference automatically. The reason being the long-term memory is just not storing the values, it is learning your preferences, your priorities, your tone, everything every time you talk to the agent. So this is how agents can evolve from being very reactive chatbots to a truly intelligent assistants. And just not only a short term and long term memory, in addition to the basic short term long term memory, agent core has got some more interesting features on the memory. The one feature is that event branching. So what this feature is, this feature allows to create alternative conversation path which use useful scenario like message corrections, or you are replying a conversation from a different point, or handling a parallel user intent. For example, you say, if user says you are trying to book the flight ticket, say from New York to Dallas, and then suddenly you change the destination. Hey, wait, I'm changing my destination, not Dallas, now I want to go from New York to Chicago. Okay, the agent can get a new branch of the previous message using a structure like this. Yeah, that means there is a edited conversation, the event id is event to branch from that event id like that, and then it build that JSON. This enable the agent to maintain the logical context while respecting edits or diverging paths. So just like how we might explore different ideas in conversation thread. Second is semantic search. So this feature allows agent to retrieve contextually relevant memory records using the retrieve memory record API. So it powers a deeper personalization without the user needing to repeat themselves. So it finds the most relevant memory snippet using semantic matching. So that's where semantic matching, it is just not trying to do a one-to-one matching or similarity matching. So if you're talking about your say food preferences, and then when you are trying to coming and doing something else, whether you are trying to build a fitness plan, or you want to build order some food from restaurant, or you are trying to book the flight ticket, you might be using different terms. The semantic matching helps that it try to get that relevant information from the past conversation into the current context, right? That's what very is more powerful thing. You are not just pulling some information from memory. The context aware response, right? It will help the agent. That means when user is talking with me on something else, it is user is asking me to build the book the flight tickets, but I know that what was user seat preference, or what was user destination, what you want, whether you want to do some adventure, you want to do some relaxing, or you want the food preferences, it knows everything. So it can build based on the past in conversation with you, it can build that response accordingly. So putting it all together, these features are allowing an agent to be more dynamic, more responsive to user change, and more persistent in delivering a personalized assistance. Now let's look into how the long-term memory is in the action. Again, I have taken this example from Amazon, but just a heads up, this notebook has got some small issues. You have to do some changes in the code before this notebook can work. I'll walk you through like what changes I have done in the notebook, as we go along. So here the architecture is that we are trying to build a culinary agent which will store the in the conversations in the short-term memory and also in a long-term memory. So we'll walk through the different steps of how it remembers the dietary choices and favorite cuisines across the multiple conversations. So this persistent memory is what makes the agent to provide more personalized suggestions and also improve the user experience. So we are having a user asking question. I have a agent built using Amazon Strands framework. So this agent has got a tool called retrieve memories, which will retrieve the memories both from short term and long term, and then it uses an Amazon Bedrock model. So to start with, I already learned the library, so you don't have to run it. So let me first import this one, and then we are just creating a logger. I'm setting the the region as West 2. Now first I'm creating a memory using memory client. I'm creating the memory name as culinary assistant and memory ID is none to start with. Next I'm actually creating, if you see, I'm creating a long-term memory. So the memory name is what we are giving it here. Okay, and then there is a description. Here you can see that I'm actually user preferences strategy I'm following. What it means is that it will remember the user preferences depending upon the user conversations. So then we are having something like event expiry date, what is the maximum wait time, what is the polling interval. Once we are done, it will create the memory. Okay. So I'll also show you where the memory get created. We can also go to the console now. This is creating memory. First, you can also go here. I'm in the US West right now, so you can refresh it here. You can see that it is still creating. You can go to build. You can click on memory here. This is the memory it is creating. So the memory is being created in the Bedrock. Next, coming back here, it is still creating. It might take a few more minutes. So let's pause this video and then while the memory is being created. So now we can see that the memory is created here. So the memory is active now. We can go back and then hydrate this memory. You can, that's what here you can see that we are giving the user preferences memory strategy, and then there is a memory space, a namespace is being given for the memory. Now, so we need to create who is the actor, the session ID, namespace ID. We'll hydrate this memory with some shorter memory, some messages. Just we are simulating the way user will have a conversation with the agent. So we are simulating that. So for that reason, we are creating some messages, similar to how we have chat, and then we are hydrating these messages into the shorter memory. And then the agent the long-term memory will learn the user preferences from this shorter memory. So now conversation is stored in shorter memory. You can see that I'm creating event with the memory ID. Now let's list this event. Now you can see that every message, every conversation I had with the agent is stored in the shorter memory, right? So now what is happening behind the scenes is that what is happening behind the scenes is that without you doing anything, the agent, the long-term memory is analyzing the conversation for any preference indicator. For example, if you see statement like, I'm vegetarian, I really enjoy Italian cuisine, it is actually storing that this user likes, or I live in a particular location. It is saving all the information about all the conversation, like what is food preferences, the location, the cuisine the user likes. So everything is being stored in the long-term memory. Now we need to now we'll see how to retrieve these from the long-term memory and then use this as part of our agent. So for that, let's first execute this. So it might take a few minutes. Again, let me also pause this. So now you can see that I have stored all this information, right? How can I help recommendation today? I looking for some vegetarian dishes this weekend. Then it is saying, the user is saying all his preference and everything. Now you can go back and see, now I retrieved from the long-term memory, what is the user food preferences. Now you can see that it is actually understood user expressed strong interest in Italian cuisine and vegetarian dishes. His preference enjoys Italian cuisine. And then user explicitly mentioned enjoying tofu and fresh vegetables in vegetarian dishes. So it has learned based on the conversation. Now we have the shorter memory which we hydrated to simulate the user conversation. From the shorter memory, the long-term memory learned the user preferences because we have configured user preferences as a long-term memory strategy, and then it has stored the user preferences in the long-term memory. Now let's create an agent. Okay, so this is where some problem is there. I was unable to use this agent core memory tool provided, so I did some small changes. I commented this part in the notebook they gave, but I have used I'm just passing the memory as a tool into the agent. Now I'm creating this Bedrock model, so now I'm going to run this. So now my agent is ready. Let's simulate some conversation. Again, let's do this one and see. First, I'm saying I'm vegetarian and I prefer restaurants in a quiet atmosphere. I like Italian cuisine. I live in Irvine. Now, in the end, I'm asking, give me a restaurant recommendation based on my food preferences and location. Let's see what happens. So now you can see that since you are looking for a vegetarian friendly restaurant with quiet atmosphere, here are some recommendations. It is giving some recommendations for me in the Irvine area. And I didn't mention anywhere else that, you can assume these are all the past conversation with the agent, right? And this is a current conversation. You might have completed this conversation few days back also. And you are coming back today and then asking this question. Okay, show me all my previous recommendations. It is showing you because it is remembering all your previous conversation in this one, you had with the agent. And you can see that we can also see here both the short term memory and long term memory will be created here. Yeah, I think and then they also have 3 different ways to access. They can use Python or TypeScript or JavaScript. You can see the memory details here, the status active, the ARN of this and everything. So all the details also you can see here. You can see the strategy. If you want to add a new strategy, you can also click new strategy here. And then you can say, for example, I want to add a summarization strategy for this particular memory. I also want to add semantic memory strategy. I can do this save changes. So now it is having 3 different strategies. It is remembering preferences. It is also summarizing all your conversations. It is also having the semantic search capability, right? So this is about the long-term memory. And then once you are done, to avoid any charges, please make sure that you delete this memory. Okay, from here, click here, say type delete, and then delete the memory. So this is about the short-term and long-term memory, and I'll see you again in the next session about other features of AgentCore.